This is the Amp Hour Podcast, released November 11th, 2018. Episode 415. Ergs per second.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, buddy. Welcome back to the... No, I guess you've... Not welcome back. I would restart normally, but I think, yeah. Hey, how are you? I think we'll just go with that. How you been? It's been too long.
Nothing changes with me, you know.
Yeah.
Still the same.
Okay.
Yep.
Sorry you didn't get to join me and Scotty. That was a good convo last week.
I didn't even know you were interviewing. I just saw it pop up and okay. I didn't know.
Yeah,
but
so
but it's hard if people don't know. It's hard when you're there with the person.
Yeah.
And then to try and coordinate with a third.
Yeah, that is tough.
Remotely is just, like it's just pointless, really.
Yeah,
it's just
tough.
You're better off just interviewing the person live there. What sort of setup do you use when you're
in that case? That was just like two lapel mics plugged into my Zoom H6, which I'm talking on now.
Thought so. Cool. Yep,
it's great. It's
just those cheap ass Amazon.
Yep.
Amazon lapel mics. Yeah.
Yep. Exactly.
Yep. Cool.
Yeah. So good. Man, I don't want to make people feel FOMO, but man, the SuperCon this year was great. Highly recommend people go next year. If you've never been, I highly recommend it. It's one of my favorite conferences, and just like getting to see some of the hacks up in person and like talk to people. It's always just really, really good.
Cool. How many people attend that?
I think this year they sold 500 tickets.
Wow,
so
that's a lot.
Yeah, it was a good number. It doesn't seem like that many because it's like, people are moving in and out. Some people can't stay the whole time, but
right. Yeah. Okay. Yep. So is it a one day thing?
No. It's stretched out to 3 days now.
3 days. Wow.
Yeah. There's like a workshop day and then 2 days of talks, and then there's workshops interspersed on those two, and Yeah,
that's why you'd never see 500 people in the one place, really,
exactly.
Would you?
Yep. Exactly.
Right.
Yeah, but notable things. So remember we had talked about Ben Krasnow's laser etching thing.
Yep.
Where he's putting circuits onto plastic and stuff.
Yep.
Yeah. So he showed that off. He did a talk about that. He was like the keynote on Sunday. He did a talk about that, and then he also did it with. And all these talks are available online now too. So I recommend people go check them out.
Sweet. Yep.
But then he printed with EL wire material, or like the electroluminescent, like the type of material it is. And then he did a driver circuit with a matrix. And so it was a more than that. He had 64 lines. It was a 32 by 32 matrix screen that he drove individual. Each piece of LED or of EL, like electroluminescence, was driven by a separate circuit in like a matrix format. So 32 by 32 of that, and he made it into like an ad hoc video screen. It was unbelievable.
Sweet.
Yeah.
Is that on his YouTube channel?
That's on I'll link it in. It's on the Hackaday talk that he did.
Oh, okay. So he hasn't done a YouTube channel about it. He has a YouTube video about
Correct.
it.
Yeah. I'm sure. Okay, I'm guessing he will. He'll probably give more details about it. But this was.
You don't go to that much effort and then not do a video about it.
Right.
It's kind of
And in an interesting turn of event that most people probably don't know. So he's up on stage and he's like, he's talking about that circuit on plastic thing. And he's like, you never know who you're going to meet at SuperCon. There's the guy that actually runs the company that actually does those demos. You've seen the demo before, right? Like the circuit printed on plastic. It's like on a curve inside a piece of plastic.
I don't recall, no.
Okay, well, anyways, it's in the video that he did initially. It's like, it looks like traces inside a piece of curved plastic. The traces are printed in there, right? And so we're all like, everyone's like, oh my God, the person who runs that company is here. And there's only one company in the world that does it. And so heard it, forgot it, whatever, right? And then later on that evening, was talking to Andreas Spies, who you may know has another YouTube channel, one of my favorites. He's the crazy Swiss YouTuber. And so he's there, and I'm talking to him, and he looks at me. He's like, that was me. It's my company. I was like, holy crap! So yeah,
there you go.
I didn't know that. So
wow.
it's all coming
I didn't
together.
know that. Yeah, that's
yeah. So I forget what the company's called, but like if you've been to, you've probably seen it at trade shows before, because I remember seeing it at trade shows prior as well, and it's a neat technology. So
okay,
very cool.
Yeah, but it's not actual circuits. It's just traces, right?
Like, is there solder mask over top, you mean?
No. I know. I'm talking about, is it like an actual chip? That's what I'm talking. See, is it just like a flex PCB kind of thing?
Oh, no. It's actually, it's copper traces that are deposited onto plastic.
Yeah, but there's no chip.
There could be a chip.
You're not actually creating transistors on there.
No, oh God, no.
Right.
That was, you're saying because...
I'm talking
right.
See,
yeah.
That's what, it's like that's what I'm
saying,
thinking.
Oh, is this chip printer type thingy?
Yes, that's
right.
right.
No, definitely not. Oh God, no.
Right.
No. This is a PCB being put onto a contoured plastic, basically. So it's good for like assemblies and stuff like. It would be simple assemblies, right?
Well,
it's interesting.
See, here's the thing I don't get with this is like, why when you can just order a flex PCB, which is copper on plastic?
I think this would be. I think honestly, I don't know all the applications of this thing, and it might not even be something that's going to take off. But I think like low cost. If you think about low cost applications, flex are still somewhat expensive, and so
not in the scheme of things.
Yeah, you're right. I mean, I don't know, but it's interesting at the very least. And Ben's video about it is very interesting. Right. So.
Because I picture this the same benefit as what you'd get out of making your own fiberglass PCBs. It's like, you can have it within the hour, but that's really the only advantage. Although with the plastic one, you can actually stick layers together and and do stuff like that. I'm guessing. Is it a multi-layer thing?
No, it's just single layer. Single layer right now. So
okay, right.
I'm actually not sure what the original application was. I assume it's like just high. Just really weird situations, I'm guessing.
It's just, there's countless applications for flex PCBs and stuff like that. And if you can 3D print them yourself, of course, then, of course, you can have it in your hands straight away.
Sure,
Bam, for, little complex prototypes that have to, form fit in some sort of, little tiny volume or something like that. You don't have to have a rigid PCB. And if you can do that within an hour, then there's advantages to that. But apart from that, you just order a flex PCB.
Yeah, so, that's true.
Yeah. And wait your 3 or 4 days, So,
Yeah, have you ever done flex stuff before?
I've done flex stuff, but
I've never done it before.
It's back when it cost a lot of money.
Yeah, okay. Does it change the calculations on like impedance and stuff like that? I mean, do you have to? Are there a lot of other considerations?
Well, you generally wouldn't be doing it for like really high speed stuff. Generally, but you can get controlled dielectric ones, I believe. But it's but it changes the equation. It certainly does.
Okay.
Because they're generally much thinner.
Yeah,
but not much thinner than a pre-preg, really, than a really thin pre-preg. So, it's... Anyway, you can order different dielectrics, I do believe.
Okay.
If you're doing that sort of stuff. But
so Scotty gave me some... After the show, he had some extra PCBs and stuff, and he gave me a couple, and one of them was like a processor board for an iPad. They're just like cast-offs that you could buy in the markets at Shenzhen and stuff.
Yeah, of course.
They were really thin. Like I was really surprised by that.
Yeah. They're just effectively pre-pregs, as I said. Yeah. Like people think of a PCB as 1.6, 0.8,
right, exactly.
Maybe 0.3, but that's nothing. When you're talking about pre-pregs, 0.05, stuff like that. Mm-hmm. And in theory, they buy that. Well, that's what the manufacturers. That's how they build up their boards. That's how they build up their 10, 12 layer boards. It's these multiple little pre-pregs, and you can just go, I just want the inner pre-preg bit, please. Don't build up anything more.
Right.
And they're super flexible.
Yeah, that's what I was
They're
really
amazingly
surprised about.
flexible.
Yeah. So,
Yeah.
I mean, that's got to change the assembly process. That's got to change it's just stuff that I've never really considered. Because for me, it is always 1.6 millimeter, like just rigid, cheap. You know?
No, it's very different. But the ones that you get in the iPhone, they're not all that flexible because they're like still eight layers and stuff like that. So the more layers you get, the less flexible it gets. But if you've got a single, double-sided.
This was a 12 layer though. That's what was surprising to me. So he's like, it's a 12 layer, and it was still super flexible.
Wow,
it was crazy. The two or probably like a 4 or 6 layer rather was a connector one inside like a lightning connector or lightning to audio connector. Mm-hmm. That was super flexible. Probably only 6 layers, but like the 12 layer like iPad processing board, it's nuts. I don't know.
They're super flexible. But if you get one of the 2 layer ones, wow, they're just
it's like a sheet of paper.
It's like a flex circuit,
Really?
Like they're really, really amazing.
So are they doing that though just for weight savings, cost savings, impedance stuff? Why is that the case?
All of the above. Well, impedance is better the lower you get, but then it's harder. The thinner it gets, they believe it, the harder it is to control the impedance of it, like to keep a consistency across. But then, of course, you can make your circuit smaller because the thinner diameter, the thinner thickness. When you go down in thickness, then for a given impedance, your traces can be thinner. Thinner. So.
And
because you're closer to the board. Because that's because there's
how
less,
the
maths works out.
Less dielectric material below it, you're saying?
There's less dielectric material below it, so it changes the equation. And like how you got your transmission line impedance calculator, and you've got to put in the thickness of the board. And if you play around with the calculator, anyone can do this, and you make your board thinner and thinner, then your trace for a given, say, 50 ohm impedance gets narrower and narrower. So you can make smaller traces, smaller layouts, etc., while still keeping the same impedance.
Interesting. Okay.
Yeah. Although one of the other aspect to flex boards, which people don't give a lot of thought to, but you'll see this if you open up like a camera or something, one of those complex 3D.
So now you're talking about flex PCBs, not necessarily.
Well, no.
Now
I'm talking about the combo. I'm talking about the combo. Like a lot of people think that you either have a flex PCB or you have a rigid PCB. But I don't know. Maybe the majority of flex technology out there is actually as interconnects between rigid boards. So I'm not sure if you've played with those where you actually get flex and rigid in the same board. So you effectively might get 2 boards, right? 2 rigid boards, and then they're joined by a sandwiched flexible connector. So then you can fold the boards back on each other without having the expense of an extra connector and ribbon cable and flat flex ribbon cable and all that sort of jazz, right? And all the reliability and cost issues which go along with having that extra connector and that extra ribbon cable. You can just order your 2 rigid boards joined, sandwiched with a flex connector, which is in the inner layers of the board, which actually joins the 2 boards together.
That's awesome.
It's a board interconnect system, and then you just fold them, and that's how you open, as I said, like open any modern complex, not even modern, this dates back to the 70s, 80s, where like inside a camera where the form factor is everything, and they've got to put all these little rigid boards in there and stuff like that. I mean, it's always going to be easier to pick and place and reflow a rigid board. It's like you can put your stuff straight on flex, but it's harder. So
right. You might need something below it or something to stiffen it up. You're saying, or what?
And stuff like, and when in the pick and place machine and stuff like that, it's just it's much harder to do that.
Yeah.
Often they'll combine the rigid board with a flex interconnect that joins the boards together, and then you can fold them like into a cube or something.
Someone had told me before that I think Zukin is like a PCB program that is targeted towards that application. Is that
Oh,
right?
okay. I haven't looked at Zuken forever.
Yeah.
Okay,
I thought
right. It's got
them or someone else, but where they're specifically targeting flex and like high speed applications for. I think they were actually talking about cameras, and that's why I was wondering though if there was like something special about the simulation or the layout or stuff like that. I thought you might know. So.
The simulation is going to be harder because then you've got to transition from the flex to the rigid and stuff like that. That's if you're running, controlled impedance stuff over those, over that flex interconnect which joins the boards, then that's harder. But if you've got a purpose-designed CAD software, then that would do it. I'm not even sure if Altium does combine flex rigid these days. I'm not sure. I'm not running the latest version, but. Yeah, there was talk about it. I mean, when I was working there, we were talking about adding support
it was like a way to move up market kind of thing.
Yeah, exactly. Yeah. The way to get more professional and, yep. So,
get more dollars, man. Got to get them dollars.
Yeah, yep. But that's, if you want to do a board like that, like sometimes you could have I've seen ones that are like half a dozen boards, like rigid boards, and then they're all joined together with all these different flex cables, open up any one of these modern high-volume consumer products, and that's what you'll find, and they all fold on top of each other, and it's fantastic.
Yeah.
But, yeah. So I actually love that tech. It's great. It's, it's more interesting than just rigid or just flex on its own. So, but a lot of people are unaware of that, and I don't know any prototyping houses that do that cheaply.
Yeah,
but if anyone knows, yep.
Right. I mean, I think the setup cost is probably going to be the huge thing there, right? Because you have to actually spec. That's the thing I was very confused about when it came to prototyping stuff. Because I remember the first time that people were like, "Oh, well, send me a fab drawing and all that stuff." Like fab drawings mean that you're specing everything out yourself, and
that's right.
Instead of you're not using someone else's process, you're using their process, right? That's the idea of a prototype house, and you get the cost savings because of that. When you move outside of that and you're like, oh, I can do anything now. It's like, yeah, you can, but you better be prepared to pay for it.
they will charge you for it. Yeah,
right, exactly. Yeah.
And see, something like that, something like a combined rigid flex board system, if you want it, you can't just send your Gerbers off to the PCB manufacturer and forget about it, and magically back comes your combined rigid flex board. You've really got to have extensive notes on the on the panelization part of the Gerber that tells you, this part is flex, I want it in this layer. You've got to do all your layer stack. You've got to tell it which layer you want your flex on, and and how far the flex penetrates in, and what the overlap is between the boards. Because because basically you're relying on, you've got to have good physical connection between the pads on the flex and the pads on the PCB. For example, and then they've got to wedge those together. Then they've got to glue them together as part of the pre-preg stacking gluing process that you'd get on a regular multi-layer board. And then, but then you insert or half in, overlap, like a centimeter overlap or something of the flex in one of the boards as you're stacking it up. And it's really, you've got to specify all that. So even if you gave extensive notes, I'm sure they're going to come back to you and go, hey, look, are you sure? Maybe if we do it this way, it might be,
you talk to a production engineer and they're like, this is not the right way to do this, right?
Yep.
Yeah.
So
I actually, totally unrelated, but a similar process type thing. At SuperCon, someone was telling me about a newish kind of method for you 3D print something and then you leave it halfway through and you just have spikes coming out of it, or you have a flat area, and then you put a piece of fabric down, right? So you print the little
fabric,
a little bit of the base, you put down a piece of fabric, and then the heat from the next layer melts the fabric between the layers.
Yes, you could do that.
And then you 3D print onto fabric effect. Well, basically you have a 3D insert into directly onto the fabric. I was like, oh, That's a super cool idea for like costuming and
Yeah,
stuff.
you could do that.
Yeah.
Because it's actually molten. It'd go through the weave in the fabric.
Yeah,
It'd
exactly.
just melt straight through. Yeah, you could.
I'm sure it was a lot of trial and error because that must
yeah,
have been a mess. But
yeah.
super cool idea though. You think about like
it's
the
great.
the replica prop people and cosplayers and
course.
stuff like that.
Yeah. Absolutely.
Yeah.
Yeah.
Well,
They'd
we were
go
going to talk a
crazy
little bit
with
about
stuff.
3D printing. I've been doing a little bit more of it for prototyping stuff, and it sounds like you said you were doing stuff too.
Oh no, I have done stuff. I've got a thing that we found in the lab cleanup. That
Oh, really? What'd you
is
find?
interesting. So, well, because we were just before the show, we were talking about Chris's. Well, he'll tell us that making 3D printed cases and stuff. And if you remember that thermal imaging watch that I did
I don't remember
way
that.
back.
This
So
was
anyway, the world's
like an
first
add-on to the
thermal.
micro watch or what?
No. It was its own watch, and we kind of designed our own custom 3D printed case. It was like two halves that went together, and it was a watch, and it looked like a and it worked. It was a so we tore down a FLIR thermal imaging camera, and we repackaged it all into our own custom case to actually wear as a watch.
Nice.
Anyway, that was kind of cool. But anyway, so obviously we don't wear it. It's not a daily wear, and it's been sitting on the shelf for I don't know how many years ago. 3 years ago, did we do that? And
That's the problem with the shelf, man. It just sits there,
Yeah, and of course we tried to make the case as compact as possible, to fit around the electronics, and it just fitted. It just all went together nicely, and it had little plastic clips. Well, we found it, and it had burst open.
Oh no!
Right, this case had actually burst open because I posted photos on Twitter. The lithium-ion battery or lithium polymer battery, so I think it's lithium polymer battery inside, actually swelled up. Just like puffed right up, and and just broke the case wide open. It was like
You're going to have a bad time.
I'd love to see that do it. I'd love to have a time-lapse camera on that over the weeks or a month it took for this battery, or even months for this battery to puff up, right? And to the point where it suddenly goes crack and cracks all the supports and everything holding the case together.
Yeah.
So, yeah.
Oh, there it is. I see. Puffy. Okay.
Puffy. Yeah, that's it. Yep. Oops.
Not
tell us about your
in the watch realm, but one of the hacks I saw this weekend was from former guest Robert Nelson. He was on here with Jason Kreidner. They work on Beagle board stuff together, and he had taken one of the Pico projectors,
right? Yeah.
and then one of the FLIR, not the FLIR sensors. What is the other one that you see a lot of places? Is it Grid Eye? Is that it?
Oh, I was going to say Lepton, but that's actually a FLIR.
Yeah. I think it's the Grid Eye.
Yeah, there's a couple of them around. Yeah.
And so he took that, and then he put the Pico projector on it, and basically you would hold your hand up like against the wall, and it would project the heat of your hand onto the wall, and then you moved your hand, but because your hand made the wall hot, it still could detect heat and project it directly onto it. So it was like an augmented reality thermal imager. It was so cool.
Nice. That's pretty
there must
novel.
be. I'll try and find photos of it.
Like that.
Yeah.
I like it.
And it seems like something that there's surely some kind of application for that. But I always just think about Pico projectors are,
it's almost like that'd be one of Mike Harrison's art project kind of thing, one of those arty installation things.
I mean, Mike and Robert are, kindred spirits, it seems like.
Yeah, right.
So that was a super cool hack.
Right, so you've been 3D printing cases.
I have, yeah. I mean,
what 3D printer are you using these days? I assume that you don't have your own. You're using the hubs.
Well, I do have my own, but I actually it's mothballed right now, and it wasn't really worth it for me to do it. I normally what I've been doing is out of my workspace they do an SLS print, and they just charge for the material. I think I've mentioned that on here before.
Oh, nice!
And
that's pretty good.
That helps pay the rent.
Those
pretty
things
much.
are expensive.
Yeah, it's so I probably save $20-$30 per print just off of instead of going to Shapeways or something like that. I have used Shapeways too, and that was nice. The flexible, not flexible, but one of just the basic plastics. But I'm pretty much in and then the most recent one, I just hired someone in the space here to do it for me, and they were using like a TAS 6, worked great. But I'm just out of the game. I don't want to print my own stuff anymore.
Yeah, right.
It helps when like it's I can charge it for like a job, because it definitely makes a lot more sense to get it right the first time.
Sure.
But yeah, I was just wondering about like your experience of like modeling stuff like that, and if you put things together. I don't know how much you've been doing this lately, but.
Well, I don't do it. David does.
Oh, David
he's
does
the
it.
modeling.
I was going to ask this too.
He's the
you
modeling
said,
guy.
You said 3 years ago you did this watch. Was that David working on that as an intern or as an employee? How long has he been an employee now?
18 months.
Oh wow. Okay, getting up there.
I don't recall actually. I don't now.
Next
I don't
thing you know,
now.
it'll
You've
be a
got
gray
me.
beard, you know.
Yeah, no, it was one of the first things he did. So it was either one of the first things he did as an intern or one of the first things he did as an employee. I'm not sure.
Okay.
Anyway, so it could be older than I thought. But
Yeah, well, that's cool. That's great. Yeah, so I was just wondering about like modeling and stuff like that, but I guess if he's doing it,
yeah, it's easy because he's. I just haven't
CAD
bothered
capable,
to learn.
yeah.
Yes, exactly. I
Yeah.
just haven't bothered to learn.
Yeah,
You
I mean,
know?
so like my big thing is just kind of like figuring out, and like at the end of the day, like if I really need to, I should just hire a mechanical engineer, I guess. But it's been nice for like simple case design stuff. I guess the balance point too is, I'm somewhere between. If I'm making like 10 units, is it better for me to constrain the board for a off the shelf case, or is it better for me to use an off the shelf board?
I'd use an off-the-shelf case. Really, they're nicer, right? Because they're injection
That's
molded.
true.
They're perfect. They're exactly what you're getting. You can just buy it from DigiKey, have it in your hand, and like no dicking around.
Yeah.
Like seriously, if use an off-the-shelf case.
Well, this was like a proof of concept too. So I was actually taking a bunch of like dev boards and shoving those together and then kind of printing around it. But I think that in the next rev, if I do I will do a custom board if I get to the next rev, and then I think probably the injection
for
molding
a 10
thing.
of like you like when you're doing consulting like this, you don't want to spend. Well, unless you're charging for it, I guess. But like you don't want to spend. You don't want to spend an extra minute even thinking about a case, because it takes hours and hours to design a case, and then you make little tweaks here, little tweaks. Oh, wouldn't it be cool if I did this? Don't.
Yeah, right.
No, just get a damn case which looks suitable off the shelf, and then just design your board around that, and it's going to look fine.
Yeah,
You know.
that's true.
And
well, the other thing I
it's
think about is like, so I had another person talking to me about like, well, we're going to go to like, 200-300 next year, and we're going to do an injection mold. And I'm like, oh, wow, that is a lot lower than I thought it would be for for a tool, like just the amount. And I was like, I personally wouldn't do that. I would, stick with off the shelf as long as you can for especially for production level stuff. Like I would never, I would never do printing for a production level thing.
You'd never do 3D printing. Well, we talked to Marcus at Heidelberg Electronics donkeys years ago, right?
Yeah.
And he did that. What was it? What was the Kickstarter he did? The ninja thing. Yeah. The ninja blocks.
Oh, that's right.
Ninja blocks, and it was very successful Kickstarter.
Yeah.
But they promised part of the appeal because 3D
that's right. It
printing
had that
was
little
cool
tag coming
back
out
then.
the side. That's what I remember about that thing.
And
Ninja blocks.
back then like 3D printing was the hot shit, right? Yeah. So like it was the hottest thing. So we're going to 3D print the cases, and he said that was the biggest. Never again. So they and of course they got orders for thousands of them, and they had to buy more 3D printers. He was telling me, and at home they had a whole room with these 3D printers just running 24/7. He said it was just horrible, like and the quality's not that great, really.
No,
I
agree. Yeah, right.
That's okay for a one-off, but this is like a thing that you send in, backers. Like people are paying for this. It's like. Like you can get a good one, like a nice SLA print or something, like from a $100,000 machine or something like that.
Well, I mean,
okay, it's going to be reasonable.
I know some people who've done that with I think they were doing like maybe in the high tens, low hundreds kind of thing,
right?
And they had like SLA machines. I think like the Form Labs one, which is a nice machine. But, I was like, oh, I should like go and look at how much the goop costs. You buy like a bottle of goop.
Yeah.
It's like a kilogram worth or something like that. And you get like, I don't know, 20 prints out of it, but it's $150, it adds up real fast.
It adds up real fast. And then it takes time. Like these things don't, to print a nice detailed case is like 3-4 hours, a couple of hours for one case. It's like, you're going to be kidding me.
Right.
No thanks. It's a mugs game.
Yeah, I think you're right. It scales linearly is the problem for that stuff. So
yeah, it's nuts.
Anyway. Yeah, so I think this would just be a low run thing, but I probably in the next one I'll change the board enough, then it'll be enough of a custom board that it would definitely fit in a case like that.
Speaking of cases, the infamous Micro Supply. You've seen a concept drawing of that.
I have.
The new one, like a 3D model. I think we're probably going to change it. We think, because we were going to.
Truth in the universe, Dave, is that you're going to change it.
We're going to change it, right? Because we were going to use a custom extruded.
Got it. Yep.
Alloy case, right?
Right.
And no, we think we're going to go to a 2-part cast one now.
Oh, okay.
So we're going to have because I've done a video on this. Yes, I have. I've done a video on this of how to actually do SMD thermal heat sinking in an extruded aluminium case design.
Yeah.
And it's not easy.
I forget what it was about.
Did you?
Yeah, I think so.
Right.
Yeah.
Yeah, and it's like it's a pain in the ass to slide your board in and yet get good vertical contact pressure on a SMD. So we're thinking maybe we'll just do it as a cast, a 2-part cast, screw it together with screws on the top, and then bam, it's easier to sandwich stuff in terms of heat sinks than it is to slide, and then it's just infinitely easier, and we think it's kind of going to be more rugged and look cooler probably. So and we don't think it's hugely expensive.
You're not doing the PCB plating or PCB structural element, are you? Like you do for the microcurrent?
No.
Okay.
No. It's going to be a top and bottom, die-cast alloy cast thing. And it'll sandwich together, and the board will be in the middle. We might do a PCB front panel. Who knows?
Well, that's cool. Yeah, that's great. And it's going to have knobs or buttons? I forget. Or
you'll
both.
see.
Okay. TBD. Cliffhangers on cliffhangers, folks.
Yep.
Wait, so you're thinking though, you're rethinking about this for the assembly aspect? Is that the idea?
The assembly aspect, is a pain, because we came up with this convoluted system where we had the extruded aluminium case and have a big cutout in it because it's got an LCD and it's got to slide in, and it gets complicated real quick. One aspect can be a showstopper.
Totally. Did you guys start assembling these?
Not a showstopper, but.
Did you start assembling them yourselves or anything, or no?
No, we started assembling in our mind. It was a thought experiment,
Yeah, because that...
paper.
I think building the first 5 is usually a good indication. It's like, what the hell did we think here,
No, it's... Yeah. And it's not hard to... we're both experienced. It's not hard to imagine what the problems are going to be.
Right.
It's pretty easy. Mm-hmm. For anyone experienced in this sort of thing, it's pretty easy. And we're just, and then we're going down a road where, look, we can make this work if we have this other custom plastic molded clip thing. And then we ended up starting to design all these other solutions to make this extruded case idea work. We could see ourselves going down that rabbit hole.
Right. This is the mechanical equivalent of doing rip up on a PCB design. You're like,
right.
Starting over, moving where the processor is. That's not going to work,
And it's just, and in the end we just went, well, no. And David's done a 2-part case project, cast case project before, and it looks nice, and and we just went, let's just go for that.
Yeah.
It might cost us more in tooling up front, maybe, but
So it's going to be it's a die cast case, is that right?
It'd be a die cast case, Yep. But the good thing about that is that you can have it machined. You can have prototypes machined first.
Yeah, right.
So it's a good, like you can't machine an extruded aluminium case, right? Really, it's like, or maybe you could do it as a 2-half. You know, if you got the 2/2 things, and but if you're going for a 2/2 extruded aluminium case, you may as well go for like a die cast instead of extrude. But extrusion is cheaper. Extrusion's cheaper for tooling. It's cheaper for in volume and stuff like that. But it's not as sexy.
I've never done a metal case before, so
right. Yeah.
Why
anyway,
why
it's
metal
cheaper.
instead of plastic?
Because we need it as a heatsink. It's a power supply.
Oh, okay. So you don't want to put an external heatsink in there?
No. We think that's a bit daggy. So it's better off to integrate, and it's more rugged and blah blah blah. You know. Yep.
Big metal box.
So yep.
You gonna do some pick and place yourself? No.
I know this is segueing into you know my.
This is just, of course we're not, but let's just segue into it.
That's dumb. Our board's getting complex though.
Yeah.
Like there's this, we've got to add a filter here and this to this, and geez, there's going to be a lot of the bomb count is high.
How many uniques?
I don't know at the moment. I haven't done a recent count, but it's double what we originally had. We just keep adding stuff. It's just.
The problem is you don't have a product manager who's like, yeah, you're making this is going to cost too much.
Yeah. But, well, it's not, we're just talking passives, really.
Yeah.
It's just like lots of, and little, cheap transistors and, stuff like that.
Before, but have you ever written a data sheet for the overall product?
No.
Someone told me that it's like a method of like, they're like, well,
I do know that. Yeah, you're right. The data sheet. Yeah.
Yeah. I mean, it's interesting too. Cause I know a salesperson who actually would go and sell that data sheet, which is.
Yeah, exactly. I don't like that. See, David's a fan of doing that. David's a fan of like, I need rigid specs up front or bugger off. Right. It's like, no. See, I don't like the inflexibility of that.
Well, I mean, I think the idea is you make them rigid, but they're squishy underneath.
Yeah, well, see, then I go, well, what's the point? It's like, it does tend to give you some focus.
Right.
That's why David likes to do all the 3D modeling up front to know what it's going to look like, and then there's our target.
Right. I think that's good too, especially if you're like,
and it's not bad.
We can't go any further than the outside of this. You get to go to the walls of the case, and that's it. So do what you want.
We've talked about this several times before. Is that you often choose your case first, and then you design your product. We're just talking about that 10 minutes ago, and design your product around that, and that gives you that. Often the case might give you your constraint, for example. Rather than say, there's like, this is how a lot of, Kickstarters or any project can come undone, is you've stuck to this spec and this feature set of what you want when, like at all cost.
Yeah.
Right? And it might cost you 5 times more than if you just lowered the specs slightly, it's half the price. Or something like that.
That's true. Yeah, arbitrary specs can also get you in trouble. It's like asymptotically approaching.
They can too.
Yeah.
Yes, they can. But, so there's pros and cons both ways. I mean, there's no ideal way to do a design. If there was, everyone would be doing it, right? They'd be teaching it in university, right?
Yeah.
This is how you design a product, right? So,
yeah. I think I mean, unfortunately, I think, so I've been on projects before where by the end of the product, you've designed stuff for 99 out of 100 people, and you're still trying to please that last one person.
Right, yeah.
And I think in your case, the problem is you're that one person. Yeah.
Because it's my
Of course. Hey, I'm not saying it's good or bad.
Exactly.
I'm just saying that you are a finicky customer.
Sure.
I think there's lots of documented evidence that you are a finicky customer, specifically in the test and measurement realm. So,
and
there's
tell
that.
someone who cares.
Right,
Yeah.
Of course. Yep.
Oh, boy.
Yep.
Yeah, but no, pleasing the one you can spend, you can double your price to please an extra 0.1% of the market.
Right, exactly.
And sometimes you just got to go nope.
Right.
Yep. Doesn't work.
Well.
And it's different depending on the industry as well. And like it's not just the fact that there's different ways of doing things. Some industries can only work in a certain, are best served by a certain method.
Are you talking about the undersea cable or undersea method like you used to work in?
Oh, no.
Like super high spec ADDs and stuff, or what?
Well, it is sometimes. But no, you could be talking about the airline industry. How do they design a plane? right? You could be talking about the automobile industry. How do they design a car, right? They've obviously got methods and procedures in place for a reason, and you don't deviate from those,
Yeah.
So,
Yep.
yeah. But sometimes you're just thankful when the customer comes. If you're a designer, you're a like you are at the moment, a consulting engineer, right? Sometimes you just love it when the customer comes in and goes, "These are the specs. Do this."
Yeah.
The end.
Oh, constraints
Done.
are the best
Right?
sometimes.
Constraints can sometimes be the best thing ever.
Yeah.
But if you're trying to design a successful product, they can also be a hindrance. So just be careful.
Grass is always greener.
Yeah.
And the grass shall be Pantone color number 4421. Yeah.
Oh dear, dear.
Well, I am firing up the pick and place again this week, and another go at that on the Neoden.
You're physically doing it yourself? There's no
Yeah.
one there holding your hand?
No, there's no one here to do that.
Right, okay.
It's just me.
And they let you use this thing?
Yeah, well, it's the one you saw. You saw it at that trade show.
Yeah,
It's not like particularly nice.
Yeah,
It's,
it didn't, right? It's
the
a
Neoden
Neoden.
4. Yeah.
Right.
Yeah, so I'm trying that again, and I've done it. I've run it twice now, and honestly, the hardest part is I think there's two hard parts. One is getting the files kind of ready to go for the kind of less than standard software. I'm not saying I don't know any other pick and place software. I just know that this is
Right.
It has a feel to it. It's not great software, and
Okay.
yeah, there's 3 buttons you can load up on the first screen. Here's my measure. There's 3 buttons you can use on the main home screen. One is like edit a job, one is save a job, and one is run a job. And if you hit run a
Right.
job before you've edited a job, the whole computer crashes. So
nice.
not a great experience. I learned that. That was the first thing I learned, though. It's great.
Yeah, right.
And I will say I did make an intro video. I still need to edit more of the videos, but I made an intro video about it. If people are interested, so posted that on my.
We are interested.
Text Electronics.
Posting.
Yeah. So, so I've done it once before, and so that was one hard part. The other one is the which I didn't realize the first time through. So I was doing a bunch of LEDs on the original board. I was doing that DEF CON badge that went nowhere. And so it had like almost 300 LEDs on the front side, right? And so
Which is
the
perfect
LEDs
for a pick and place.
Exactly.
Perfect.
Exactly. So four PCBs on a panel times 300, 1,200 LEDs. Holy
Yep.
crap.
Oh, yeah.
So
Yep.
lots of picks,
Yep.
lots of places. And the thing is, the calibration on the LED, the 0603 LEDs I had was fine. Have I talked about this? Maybe I've talked about this. We'll go with
Possibly.
Yeah.
Was it
I
they
know
came
you
on
and I
the
have talked
tape
about it,
in
but
the
I don't know if
different
it-
orientation or something? Is that the...
No, nothing about that.
No?
It was just it was pre-calibrated. I didn't even realize there was a calibration. I just started using it and it worked, right?
Right.
And then the tough thing for me was then I finally, I redid all the files for the backside and got that all worked out. And there was, obviously other feeders had 0603s and, capacitors and resistors and a bunch of other passives and stuff like that. And I didn't realize that there was a calibration step. It just worked the first time through with the LEDs, right? And then the resistors and capacitors I started running, and it was the Z height was calibrated wrong, and so it started just hitting the board, and like these things were like ping, 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 and just like flying everywhere. Yeah. Oh man. So not great. Yeah.
Yep.
So and so that's
Wow.
the part that I have not figured out yet is like the
Right.
this is like we've talked about like the part of pick and place machines that's really important is the feeders, right? That they don't jam
Yes, of
up,
course.
that they well calibrated, that they they understand where they are, and I have to learn that step still. So
Yep.
it'll be interesting. I don't know.
So these pick and place heads, they don't have like they're rigid, are they? They don't have like the ability to like sprint, like to like like if you program the Z height wrong, then it's going to crush your component or whatever. Is that
No. They're spring loaded, so they will
Right,
they do have
they're
give.
springy.
And then
Right.
even when if you put them into the board too hard, the board will give as well, right? There's always flex
right?
in
Of
the PCB.
course, yeah.
The problem is when it like you think about like the PCB getting hit by a component attached to a vacuum head and being pushed down into the board is that the whole thing flexes. And then when the nozzle lets go of the air and it pulls back up, it's like it's on the downstroke of a trampoline. And then the part just goes kapoom and into space. You know?
But your solder paste is the tension of your solder paste is supposed to keep the part there and not flying off. I mean, how much force is this thing flinging down with?
I mean, that's the thing.
Lots,
it was
obviously.
Real bad. It was really, really bad. Yeah,
Right.
So I just need to kind of learn that step. And so another thing I learned, though, is that, so I was doing, like I said, a ton of LEDs on the front side, not many parts on the back side, and not many boards overall, right? So I placed probably, I think I did 10 boards. So that's nearly 3,000 LEDs. Great. But then I did the backside, and the backside had, one high cost switcher, right? Not even high cost. It was just a switcher that was, $2. And it was a SOT 23 6, and I didn't have many of them. I bought enough parts for 10, and so I didn't have nearly enough tape. And so at that point, I was just like, I guess I'll just skip the stage. Yeah, exactly.
Yeah, no. You don't. If you've got to pick, you don't have to pick and place every component. No,
I don't. Yeah, I don't plan to.
Sometimes it's just like in this case the LEDs. Just do all the LEDs, and if then you've got a quad flat pack, like really easy to solder.
Yeah.
Just get in there and swipe it along and boom, do it by hand.
Oh, you don't even. The stencil still puts the paste down. So and I think this is how a lot of the macrofabs of the world do it too.
Unless you deliberately knew what components you were going to do, and then modified your paste mask.
Oh, your
to
stencil,
not put paste in your stencil to put,
Yeah.
Yeah. So, but you have to know that ahead of time that I'm going to place those by hand, and of course your CAD program will automatically generate the stencil, or no, you could design it in so that you can design it into your footprint, but then you'd have to modify
let this layer through.
Yeah, exactly. Go in and modify a part to not show up on the stencil. So,
yeah, I will say too. I created my first panelized design ever, which I know sounds stupid, me having done electronics for 15 years, but I always just had someone else panelize it, or I just got single PCBs.
Or you let the PCB manufacturer panelize it for you.
Yeah, exactly. Yeah,
so that's another service that they offer. You just Okay, so you actually panelized it. Yep. Cool.
Yeah. Actually, Peter Ezdentemsky, who's been on the show before, he had this really great live stream where he was showing how he did that on his design in KiCad, and so followed along, and it's doable.
Cool bananas.
So I think the thing that I always
because KiCad doesn't have a panelization tool, does it?
That's correct. Yeah, and then people said Altium's is really, really good for that kind of thing. So it's a little bit janky.
Yep.
With the panelization, but it's like at the end of the day, it's like copy paste, for stuff, and it can do that.
I've done both. I've done copy and paste because sometimes like the Altium one, well, it might be much better now, but sometimes it wasn't it worked well, but it often wasn't magic. You got to do something custom. Often I've gone, look, I'm not going to, even though I've got the panelization tool, I'm not going to do it. I'm just going to copy and paste and do it that way.
And have different versions of the same board. Yep. Yeah. I think the thing that was kind of bugging me, I kept asking around, and I should have just asked you or someone on here, or just asked someone else. It was kind of a stupid waste of time, but I always thought there was, I know there are standardized sizes of panels, but you don't have to do that. A PCB panel is just a big PCB with multiple designs on it. And
it is, but they buy them from the manufacturer as a standard size.
No doubt, but when I send it to if I ask for a panel from a prototype house, a low cost prototype house, they're just going to make my design as a big PCB, right? And I'm not doing a full PCB size, right? Or sorry, full panel size. So like my last one was like, I don't know, 100 millimeters by 300 millimeters or something like that. And that'll fit fine in the Neoden. It's adjustable. I can change the rails and stuff like that.
Well, that's the thing. Panels are large. The panels that they order from the manufacturers, they are large, and often they will not fit in pick and place machines. So it's like, I've got they usually specify them in inches. What is it, like a
18 by 24.
18 by 24 inch panel, right?
Yeah.
And it's that's big. Right? That's pretty
that's really big.
And that, often won't fit in a pick and place machine. And it's like you can't just magically fill that. And many companies come a gutser when they've designed this big panel just because that's what their PCB manufacturer told them was the maximum panel size, and they didn't talk to their assembler. And then they got these big expensive panels made, and they shipped them off to their assembler, and their assembler went, this doesn't fit in our machine.
Yeah, I know the Neoden. It has, I think, 400 millimeters total space across, and the rails can't go all the way to the edges. So, yeah, good luck with that.
well, often because boards will feed into a pick and place machine, your boards can not be an unlimited length, but they can be longer than height is usually the problem. So
Yeah, I remember Mike when he was talking about that really crazy thing for his.
Like a meter long or something.
The installation in London. Yeah, it was like 6 meters, not 6 meters. I think it was maybe.
But the actual PCB was like a meter long or something. Was the PCB
I think
a meter
it was 2
long?
meters long. It was just on the edge of what was possible, I think.
Yep.
Yeah.
Yep.
So.
And then he had to find an assembler that could do it. Right?
Yeah,
it's not you can't just go to your local assembler and expect them to be able to do it. It's like, no, somebody's got to have the machine and the technique that's capable of doing that.
Right. Yep.
So,
I guess the thing that I wanted to get across is that, like, I always assume that there's standards, you know what I mean? Like that there are like, here's your laundry list of things you can do, but like it's much more open loop than I ever gave it credit for.
Is.
And so,
totally.
And it's like, more rope than you can hang yourself with, but like, I just wish I just didn't know that, and now I do, and that's good. But I wanted to pass that along.
And once again, you go to a large panel, the board warps when it's in the pin, because as you said, the pressure of the head comes down. That's bad, and especially when you panelize it, because especially like if you've got routed slots on there, or even worse, V grooves. For example, if you've got a large panel like 12 inches by 12 inches and it's V-grooved on there and you've got hundreds of little boards, try putting that in a pick-and-place machine and held by just the guide rails at the edge. Your board will just snap in half as soon as the head hits it, right? It's just going to fold, right?
Definitely.
So because those V-grooves are designed to snap really easily. So just be careful what you wish for. Oh, I want a nice panel that snaps easily. Yeah. Good luck with that. So often, so the way the manufacturers will overcome, the assemblers, will overcome that is they will design a custom holder for you, right? That your board sits in this custom holder, like this custom carrier, and it's custom designed, like it's milled out to fit your panel exactly, and it's got supports in various locations on the board, so your board doesn't warp and snap. And then, especially if you've got a thin board, like we're talking about earlier in the show, right? If you've got a 0. Even a 0.8 millimeter board, right? On a larger, once it gets largish, they're pretty flexible, right? And they're common as mud.
Even the panels were probably again they're probably pretty similar to what I was talking about, 100 by 300 millimeters. I mean, like not like super big.
That's not a big panel, no. No,
yeah, right.
No, that's a small panel.
You got 4 boards on it, right? But like, they must be cranking through because, it's Apple.
I think I might talk about this in my design for manufacturing tutorial video, my old one, but I'm not sure. But anyway, they will make you a custom carrier that your board fits in, and they'll charge you a one-off tooling fee for that. It might be $500 for a custom carrier or something like that.
Well, you got to make a couple probably, right? I mean, if you had to reload them every time they go through, right?
Oh, yeah, you make a couple. They'd either usually make them out of wood or something like that. They'd like and they put them in like a CNC milling machine that'll mill out your the slot that the cavity that your board fits in and stuff like that.
Yeah.
So but somebody has to design that. They've got to make them, and then it's only used for your board. So it's absolutely no use for them.
Engineering effort, right?
Yeah, and they don't want to store because they're quite they're large. They take up space. So you might go back to them 6 months later and go, hey, I need some more boards made, and they go, oh, sorry, we actually turfed out the carrier. You're going to have to buy another one. Because they're not going to keep it. They're not going to waste space in their factory holding your custom carrier that you may or may not use in 12 months' time.
Right.
Yep.
Yeah, you better get that and store that on your own if you really want to.
Yep. Oh, yeah, no, you could ask for it back. Just say, oh, take it back, please. It's yours. You've paid for it,
Yeah, that's right.
Yeah. Yes, no, penalisation there's lots of, it's very fluid, as you said. It's very non-standardised. It's all, you can do pretty much anything, but there's pitfalls in everywhere, all over the shop.
Right.
No pun intended.
Yep. Speaking of all over the shop, how's the move going? I guess we didn't talk about that at the top.
Yeah, no, it's going to be. It's going to be it's going to be slow. Oh. It's going to be slow. I don't get internet
in 6 months from now.
Yeah, probably. I don't get internet there until that's been installed next Wednesday. So I can't. So I'm still in my office at the moment. So I can't move my office. There's just no point because there's no internet. That's a killer. So that's a showstopper. But anyway, no, it's just there's so much crap in the old lab. It's like, now it's like I think I'm going to have to make a blanket rule.
Dave.
Yeah, I know. Nothing. You've been there, right? Nothing goes on the floor. Everything either goes on a tub or in a shelf. I think that's a big one too. Yep. Even though you've got all that wasted volume under the benches, right? That's all wasted volume unless you've got shelving under the benches, maybe under the workbenches. But I might do that, but I'm not going to put stuff on. Nothing goes on the carpet. It's like goes in a tab or
I think that's. I was moving recently. I moved apartments recently, and that was the big thing. When it stops feeling uncluttered is when I built the shelves that I had in my room, and then I put stuff up. Getting stuff up really just changes the feel of a place.
Yep.
And so that's good. I mean, that's a good rule to have for sure. I think you got to make a floor detector or something. I don't know. How do you police it for yourself?
It's easy. I put a live webcam in, and then I instruct the community to. Yep, they pester me. First
person that sees something on the floor gets a free BM235.
Yeah, that's it. They get a free meter. Anyway, so instead of every time I upload a video, instead of typing first, I'll instruct people, first comment, Anyway, instead of typing that, they'll type clean the lab, or clean that box over there. I can see it on the webcam.
Right.
So that's how I'll probably keep myself. Yep.
It's good. Community involvement. It's very important.
Yep.
Yeah.
No, that's important. Well, because I own the other space. It's mine. It's it just grew to be. I grew to be complacent there. Whereas this place is not mine. I've got to keep it in good nick, and and it feels good. Moving in, there's so much space. It feels like there's so much space now, and I want to keep it like that. So, yep. So yeah, I'm going to put more. Huh? Yes. What did we mention?
You put more what?
No, it's all right. I was just going to talk about organising the lab, but nah.
Oh.
I'll
do it. Try and make a shitty segue into me mentioning you in my talk. I did a talk. You said something about boxes. I was
you mentioned me in my talk. Okay. Yep.
Yeah. I put you up on screen actually.
Oh, toolbox. What?
So I did a talk at SuperCon, and I went over a bunch of circuits. And I mentioned your EEV blog 262, I believe, the soft circuit, the one where it's push to turn on, push to turn off.
Oh, that circuit. Oh, God, that's old. Yeah, right.
Yeah, that was old.
What about it?
It was good. Still good.
Why did
you
were
up on screen because I went over 30 circuits in 20 minutes.
Oh, okay. Oh, that was the theme of your talk, right? 30 circuits in
that's right.
20 minutes,
yeah.
right?
Yeah.
Okay, right. Cool.
Yeah.
All right.
Yeah.
Thank you very much.
A lot of different circuits in there, but
you will
good.
feature in my next video. I've already shot it.
Oh no, I better hurry up then. I got to release the. I know what that is. I gotta go.
What?
I'm gonna go home and record some more of those videos tonight. So this will come out after that, I'm sure. I made.
What?
You
No,
got
I
the
don't-
mailbag?
No, I didn't get what mailbag. No.
Okay. You didn't know. Oh, then never mind. It's buried somewhere in your mail pile.
Oh,
But I sent you something.
you've sent me something, really?
I sent
okay.
you something. Yeah.
Sorry.
That's what friends do, Dave.
Oh, okay. Right. No, sorry.
Yeah.
All right, great. No, it's not
All
that.
right,
No,
good.
it's not that. So
Crossovers on crossovers we got going on here at
Yep.
the Amp Hour. So,
well, I
yeah.
am. Speaking of which, I will be in the next. It's already released to Patreon supporters, but I will try and find the link. You know the Techmoan channel. Techmoan
Techmoan.
does like vintage
Spell
tech.
Oh no, I don't know that one.
Techmoan. Moan. MOAN.
MOAN. Oh.
Yep.
No, I don't know them. Okay.
Techmoan. Anyway, he's very popular, and he does like vintage electronics and stuff, like old like 80s technology and stuff like that. It's really great. Anyway,
okay.
so I have a cameo in his new video.
Nice.
So he's a big channel. I think he's got like 700,000 subs or something. It's big.
Oh, really? Okay. I'll check it out.
Yeah.
Sometimes that's just how it goes. You just don't hear about it, and until someone tells you.
Yeah, right. No, well, there's so many channels. Like
any other gems in your YouTube watch list that we should know about here, Dave? I mean, come on.
I don't know. I do enjoy the history guy.
The history guy. Okay.
The history guy. There's a random one. There you go. Which isn't really.
Yeah.
Oh no. Okay. No. Once he did a engineering related one, but no, the history guy. I enjoy the history guy.
Okay.
There's just a random. It's just a random one. So anyway, yes, Techmoan. I do a cameo in Techmoan's latest video. It's right near the end. You've got to look.
Okay.
Okay. Spoiler alert. It's like 20 minutes in or something. He doesn't make short videos really. So
Yeah.
I will send you the link.
Okay.
Bloody
I sent you
multiple
a link
screens.
too
Can't
of
see
the
them.
all the slides I have. You are slide number. God knows how many. And
I'll
many-
put it in
many
my
slides down.
resume. I'm
Yes.
slide number 32
You're
in.
Yeah.
Love it. Oh, it's
Yeah,
okay.
no, there was
It's
a-
video.
I was trying to do like
Who-
circuits that I think I mentioned it on here, but I was trying to do like circuits that would like save your product from blowing up, or
Right.
Um,
Okay. Stuff like that.
yeah.
Geez, you spent a while on that one. Some of them you spend like 2-3 minutes.
Oh yeah, some of them I did. Yep.
All right.
Yep. I was definitely racing. by the end.
Who shoots the videos and edits and at the conference? Do you hire someone to do
At
that?
the SuperCon? There's
Yeah.
someone, Jordan works for Supply Frame, and he does all the live streams too. So like all those events that I used to go to in San Francisco, those are now like all live streamed too. So they're good
Right.
stuff.
Cool.
Yeah.
Because that's a lot
we had
of work.
one other thing on our list for this week that was kind of random. What was I don't remember why I asked you about it, but it was something about solar. And we were going to talk a little bit about solar because you said you haven't been checking into it.
Oh, the Carter White House.
Oh yeah, that's right, because we had a thing on our list about Jimmy Carter's solar panels on display in a factory in China.
That's
And I
funny.
was asking about how you're yeah, sort of.
Yes, you're asking how much. It is. It's hilarious.
I mean, yes, it
You're
is.
asking how much.
Okay, yes, I agree.
They're just going. Like I totally forget about them. Like I just like as I said to you before the show, I don't have an automated system anymore. Well, no, I do. I've got the GSM. I've got the newfangled GSM automated system, but for the PVOutput.org system, I don't have an automated system anymore that uploads the data. So I've got like an app on my phone that I use like every month or something, and it just downloads the data and then uploads it. But I can't remember the last time I actually did it because I've got to remember to actually do it once a month. And the thing only holds like 30 or 60 days worth of data, before it just, You know,
What, it
it's
like
only got a
erases
certain
itself
amount
or
of memory.
something?
Yeah,
Yeah.
it actually erases it. You know, it only keeps like the last 60 days worth of data or something. So, yeah. Anyway,
Well,
it's like
it's
so
interesting. I
unless
think it's like this
automated.
active thing, but it's not, right? It's like it's this thing in the background now that it's been installed.
No,
It's like,
yeah,
it's a
you just
utility
don't
thing.
notice it. Because we've got no display in that. Like some systems will have like a display in the house,
Mm-hmm.
like a little, you know, it sits on the kitchen bench and it tells you, you know, how much power you're generating. I think I can get something like that for my system, for my inverter. It's you know, it has to match the inverter that you've got.
Yeah.
Anyway, you know, like a kitchen table stand. But even if you had that, you'd
Right, you glance
know,
at it once a
like,
month and you're like, oh,
you
look,
glance
there
at
it
it
is.
once a month. Oh, okay, yeah, it's still generating power.
Yep,
You know,
yep.
like
The lights are still on. Yeah,
no.
I know.
Yeah,
That's what's crazy
no,
about it to me.
and that's even for a tech guy like me,
Right.
Who loves this stuff, right? And it's going, and it after a while, it's just, yeah.
Right.
It's like, it's just generating power. And if I installed a battery system, I'd be excited about that for the first few months, and then once again, it'd just fade into the background.
Right. Well, until the power goes out. Until the
power goes out, and then
grid goes down,
yes,
and you're
my
like,
battery,
right,
my battery
right.
system works.
Exactly.
Yeah.
Vindicated.
Yeah, vindicated. But, you know, but I've told you about the reliability of our power grid here. You
Yeah,
know, if we have one power failure for an hour every 2 or 3 years,
Right.
that's, you know,
Right.
that's as bad as it
The
gets.
biggest
Really.
concern is that you might have a computer without a UPS that you have to restart. Yeah.
It's just like who cares? Like, you know, like if you're installing a battery, you know, solution because your power might go out, you know, for an hour, it's like whoop-de-doo.
Yeah.
You know, God.
Yeah,
Read
I
a
don't know.
book.
I guess I just think about it. It's kind of like a socioeconomic type thing, right? Where it's like, it's something that's hard to get people to evangelize about because it's just like, oh yeah, it's just part of my life now. And
Yeah.
but it is something that
Totally.
could have a big impact. So it's interesting to me. I think ultimately what it comes down to, though, like, you know, speaking of Jimmy Carter and obviously the failure of the 70s to bring on the solar, aside from the cost of it, whatever, is that the economic argument is the best argument there is, right? The best argument
of
is that
course.
you're earning it back and you're eventually going to get free
Yep.
power from it, you know, that kind of thing. So
Yep, that's it.
yeah.
Yeah. But, you know, we still pay a lot for power.
Yeah,
You know,
true.
it's like it doesn't serve our needs 100%.
Right. Yeah.
Even if we had a large battery solution, might still be drawing. We may not be self-sufficient. You know.
Yeah, it'd be interesting if you did if you ended up getting another quote for more solar. I don't know if you have room for more solar, but if you
we do, because we extended the house, so we now have
okay.
more roof space. So we could actually put it on another maybe 4 panels or something
it
like
would just
that.
be interesting to see
So-
that, because you would see the cost difference then, you know what I mean? Like because the
Yep.
costs have dropped so much
Yeah.
in the past couple years.
But battery solutions are still expensive. I've run
Yeah.
the numbers on it.
Oh, yeah.
And it just doesn't add up.
It's too bad.
It really does not add up.
Yeah.
So yeah, and our power here isn't cheap either. So I
Yeah,
can't imagine
right.
what it's like for people. You know, you guys in the
I know
US
we get like
who
10
are,
cents
you know,
per kilowatt hour, something crazy low.
10 cents. Here
Yeah.
it's 30.
Yeah.
Right. So yeah, it just doesn't add up. It's just not enough power. A battery solution's $10,000.
Yeah, right.
Even at our current bill, I don't know, our bill might be $200 or $300 a quarter, is it? So 1,000. Even then, it's like 10 years.
Yeah. And the battery's got to replace that, right?
And and you're not even breaking even, and then your battery's got to be replaced. It's like it's just not worth it.
Yeah.
You know, whereas you can, especially if you consider that's a large amount of capital, right? 10 grand. If you go invest 10 grand in shares or something else, right, or even an interest-bearing account after 10 years,
Right.
even with a pissant interest rate, you still got a return on that investment. So, you know, it's like, yeah, you may feel good that you're do it, but from a purely financial point of view, battery storage solution is it doesn't make sense for us. For others, it might be. If you've got an electric car, electric hot water system,
Right.
stuff like that. Whereas we've got gas hot water. You know, if you've got electric, heaters and all that sort of stuff, it can make a big difference.
Yep. Yep.
But for our particular thing, no, sorry, not worth it.
You know, a random thought that just came into my head. I'm really grateful that the U.S. somehow standardized on a SI unit for power. We do kilowatts.
Did they?
Well, yeah, kilowatts
Really?
instead of BTUs per hour.
Oh, okay, right.
Or metric horsepower. I was just
Right,
looking at some of the other things you can convert kilowatts into. Foot-pound force per minute.
Oh, that's it.
Erg per seconds.
Ergs, yeah. Come on,
There's-
I'm a bit of an Erg fanboy, you know.
There we go. We got a show title now. Ergs per seconds.
Ergs per second. Yep, there we go.
What is an
Yep,
erg? I
sounds
don't
good.
actually know.
Oh God, I forget. Don't put me on the spot about ergs.
Sorry.
But yeah,
But yeah, all right. You guys got it right. Yeah.
yep.
I've been doing better with.
Fantastic.
Yeah, I think all of my 3D prints are now metric. No inches for me.
Right.
Okay.
Cool.
PCBs. So I mentioned that video of Peter doing the panelization, and he mentioned metric. I'm like, yeah, why am I not doing metric? I still need to switch over. I think for just I've been trying to do more metric on the traces and stuff like that, but.
I'm still not a metric. I'm still imperial for traces, but I'm anything, as I say in my videos, anything for physical stuff, like PCB dimensions, drill sizes, all that
Bolts,
sort of stuff.
nuts,
That's
whatever,
all metric.
M2, M3, M4. Yep.
That's all. Yep. That's all metric. Yep. Whereas my traces, I still can't get over. My 8th hour. It's just.
Yeah, Kaiken shows
and it
both,
doesn't-
but
and
it
help.
still is tough when you see it like one versus one in front of the other.
That's the thing. It doesn't help when the PCB manufacturers half.
I know.
There's no.
Yeah, I know. So I've been using a lot of the Chinese fab houses, and they say 0.3 millimeter drill, and then 5.5.
Yep.
God damn it.
Yeah. Right. Yeah. Well, I think most of them are standardized on the drill sizes.
Yeah.
You won't. I haven't seen one for a long time that'll specify imperial drill sizes. So that's
Yeah.
But yeah, traces. Yep, still a thing. So.
Yep. All right,
Anyway.
man. Well, we should cut this off. But good luck with your move.
Thank you
all
very
that
much.
Stuff. Powering up your lab with ergs per second.
It's the move is just it's almost gonna be a continual process. It's one of those, I need to do a video, I'll just set up this part of the lab for this video. And then
Cool.
Anyway. Cool. All right.
Talk to you soon.
Catch you next time.